So most of you are advanced users, and so some of these considerations already have been taken into account, but it's worthwhile to mention. Well, first, something very obvious, you need to have three basic aspects in place. Of course, the connected GPS, and we mentioned this because sometimes the GPS is there, but it's not connected, or sometimes the data storage is there, but it's full, or maybe it's not there. And also, very important, it requires a little bit of discipline, is do the calibration in time. Mechanics, hydraulics, data configuration, it all comes in the user manual, depending on the harvester. Data media, you will have this, you will have different devices, USB devices, maybe a card, different types of cards, older, newer. Nowadays, I'm not mentioning this because that's coming. It's not yet too widespread in the market. We'll have wireless communication. So that will be really a revolution in terms of data processing, because it will take a lot of the, let's say, manual work in managing the data. For now, we are using different data devices to download the yield data. Now, other aspect that's very important, it's different aspects that we need to consider for yield monitor calibration. So, and again, this comes in the user manual, but just to give a quick idea, there's always some degree of vibration, and and the impact plate of the yield of the yield measurement device, it's prepared for some level of vibration. However, when you go above certain level of vibration, you need to calibrate, otherwise you have errors in the readings. Another aspect, well, speed is an old aspect. Right now, speed it's already more or less managed by the GPS, but in older models, you will have a speed with other methods that you need to take into account. And of course, most typically, you have some type of weight calibration where you need to measure actual yield measurements in the scale against the yield measured by the combine. So you have to measure those two aspects in maybe one area of the field and see what's the difference. And usually we use these thresholds. The 2% difference, it's optimum, 5% it's acceptable, and more we need to than 5% we need to recalibrate. Which again, it's something that you will calibrate using the user manual. It's just things that you take into account. Platform width and height, make sure that the platform height is calibrated, so when you lift the platform, it will stop recording. So there are a number of details that and a checklist can be provided, so you take into account all this, and you will have then the checklist, you have the procedure to calibrate, which can vary from yield equipment from brands, different brands of yield equipment. So in summary, the average error of a well-calibrated harvester can be quite low, close to 3%, and that's what we're shooting for. And there's something very important to take into account at the beginning of every harvesting season. Take maybe a few hours before we start to do this calibration task. Okay. Data management. This is also something very, very important. It's more on the operator side. Uh, First, make sure that you have the correct date and time in the monitor. It has a number of implications for data processing and analysis afterwards. Then, very important to enter the field number, date, and crop. And then try to separate loads between fields or between test strips, because that's what allows you to measure each of these units, a field unit or a test strip unit, individually. So those three things to have in the, and we know it's sometimes it's not the priority, but it's very, very important to be able to analyze the data later. So we'll see later some examples of errors. If we don't do this simple considerations, then we get errors, and we'll see some examples that we got from the yield data that we're processing. We have examples of errors. So for instance, in this case, well, these are two cases, uh, one in the left and the other in the right. In the left, we'll see that the loads have not been separated. So you have this field, and this other two fields in the same let's say data processing in the same load. So that also will bring some noise in terms of having the average yield per field, and the ideal situation would be to separate these four loads. Or in this case, one field was harvested and then they harvested one corner of another field. So again, this brings noise into the processing and data analysis. There are some errors also due to excessive load division. So you see here it was separated in different loads, and we see this sometimes when we process the data. And we can recompile or recompose the whole field later, but also take some additional work and some questions and issues when processing the data. This is very, very typical, are the head errors. As you know, when you are doing the harvesting operation, you have to be considering a number of aspects. So the ideal situation is when you take a turn at the end of the harvesting line, you will lift the head, it will stop recording, and then when you enter the field again, you will put down the head and start recording again. This would be an ideal situation. Or in some other equipment, more modern, it will stop recording when there's a zero reading, but that can also induce some error because in some areas there's actually zero yield. So there are pros and cons on different methods. Or maybe in another systems, you have a pause button, so the operator can click the pause so it stops recording. But then again, when it goes back into harvesting, he may forget that he needs to click it off. So then it stops recording for the next line. But basically, what this brings, it's a lot of errors in the head, and in some cases where the operator is very clear about this error and can see the yield map afterward, and he's aware of this, he will lift the head or click the pause button and he'll work correctly. But in most cases, we'll see all this data that we'll need to eliminate in the data processing phase. There's an example of a false contact in a GPS connection. So this is also a type of error that we get. This is an example of what we said before. You have a raw map with the raw data map where you have all the data from the yields monitor, and you have a clean map where that data has been removed. So this data on the right, it's useful to do data analysis. This data on the left will lead us to errors. So that's why that's where the software comes in. You need to use your own software to clean it up, or you need to use maybe if you're working with GeoAgro in the precision farming cycle, it's part of the service is to clean and process the data. So we can use it for analysis. These are some examples of non-reliable data. Maybe in this corner, there's a lot of superimposed information where the harvesters are going in different over and over recording the data, and we might have actual yield data below those red points. Or here we can see how the harvester was moving, and we have some readings that are really not. It's not helping us trust this data. On the other hand, when we see clearly defined management zones, like production zones, like in this case, or let's see here, so you see this zone here, this zone there, this zone there. So when you see clearly defined zones, we know that that data came from the crop yields. So that's when we talk about reliable data, and that's important to recognize and to be able to use this data properly. And the conclusion is that we can achieve good quality yield maps if we take into account all these considerations. So it's just a quick checklist and about when we capture the data, and then about when we visualize and analyze the data and process and clean it up. The goal is to get good quality yield maps, and this will be, again, like our record at the end of the year. How we did, how were our management decisions, what were the increase in production, and what was the actual profitability in each area of the field. Okay, so um, so some ways of visualizing the data. We can visualize by points. We can also, based on those points, and part of the data analysis is to create areas. So this could be some basis for then analyzing this data in combination for other data like fertilizer application or seed applications. And also very important, we can do it by grid. The importance of doing it by grid is that then we can analyze this data in combination with remote sensing data or in combination with other year's yields. So this is very important that we can use yield by grids. So we can analyze then cell by cell what was the behavior, what was the evolution in each of those points.